So today our topic that we want to talk about here is productivity. There's this relationship between the labor that a firm can hire to produce output that it needs to sell to consumers in order to maximize profit. So this is another step that we're going to take to think about the way that firms profit maximize. So, in terms of productivity, there's a couple things that we want to be able to understand with this, and this relationship between labor and output, right? Each unit of labor that I hire means gains to specialization. That means that one person doesn't have to do the work of many. When I start to hire more and more people, they can split up tasks, which is more efficient, and that's going to produce more output. But at the same time that that's happening, and since we're talking about the short run, so firms can't change the amount of capital that they use to produce, they're going to run into problems because they have fixed amounts of capital. And so this ends up being like a war between the gains from specialization, right, the benefits from hiring another person, versus the scarcity problem that a firm faces in the short run because they can't change the amount of capital that these workers can share. And so what ends up happening is eventually this ceiling on capital wins out over gains from specialization, and the amount of total product that can be produced as I hire more and more people in this firm is going to fall, and eventually it'll start to curl off and actually be reduced once we get really close to that fixed capital constraint. So with that in mind, there's a couple of variables that we want to be able to calculate when we're doing this. The first is marginal product of labor. And marginal product of labor is just the difference in output levels conditioned on the fact that you've hired another worker. So the formula for this, right, is the change in output given a change in L equal to 1. At least for our purposes, that's going to be how we're going to calculate the formula. So let's go ahead and calculate marginal product of labor for these five labor amounts. Right, I can't calculate marginal product of labor when no one shows up to work, but when that first person shows up to work, output changes by 12, so the marginal product for that first worker is 12. When the second person shows up to work, the marginal product of that second worker is 18. When the third person shows up to work, the marginal product for that worker is 10. And when the fourth person shows up to work, he or she has a marginal product of 4. Now the second variable we want to be able to calculate is average product of labor. And this is pretty easy. We're just going to take the output amount and divide it by the quantity of labor that's hired. So when I'm calculating average product of labor, I can't divide by 0, so when no one shows up to work, I can't calculate average product of labor. But when that first person shows up to work, the average product of labor is 12. When 2 people show up to work, the average product of labor is 15. When 3 people show up to work, the average product of labor is 13 1/3, and when 4 people show up to work, average product falls to 11. So we always want to be able to calculate these, and an important point for us to realize here is to scan marginal product of labor, right? Because we want to understand this idea of specialization versus fixed capital. And you can see here marginal product of labor rises for the first couple of workers who are hired at this firm, and then they start to fall. And that's evidence of that fixed capital amount taking over gains from specialization. But for those first couple of workers, they're sharing tasks, those tasks become more efficient, the output procedure becomes more efficient, and they're able to increase their output fairly rapidly. So this is an important point here because this is where marginal product is maximized. Right, when that second worker shows up, that's where marginal product reaches its maximum. And we say that's where diminishing returns to labor sets in. All right, where marginal product's maximized, once I start to hire past that amount, I'm going to get less and less output because fixed capital constraints are starting to really overwhelm the gains from specialization that the firm enjoys. So we always want to be able to find that marginal product or the diminishing returns to labor point. And the way that we do that is we just see the point at which marginal product is maximized. So at L equal 2, in this particular instance, we've reached diminishing returns to labor. So now let's leave aside this table and just think generally about how marginal product and average product of labor can be graphed. Right? And when we create a graph, we want to have the independent variable on the x-axis and the dependent variable on the y-axis. And so with our graph, if we think back about what the marginal product of labor looked like at the firm that we just analyzed, right, marginal product rose for a little while and then it started to fall once it reached diminishing returns to labor. And once it starts to fall, it's never going to rise again, right? Fixed capital constraints are always going to win out here. And once that capital constraint starts to overwhelm gains from specialization, marginal product of labor is going to fall, and it'll fall for forever, eventually becoming negative if we hire too many people. So a couple of points here that we want to be able to recognize. One is this diminishing returns to labor point. That's where if I hire past this point, I'm going to, as a firm, I'm going to face lower and lower changes in my output. The second point that we want to be aware of here is right here. That's where total product is maximized. So if I hire past 2, I'm actually going to reduce the total product that can be produced. And then when I graph average product of labor, average product is going to rise for a little while. Once it reaches marginal product of labor, once those two variables are equal to each other, then you'll see average product reach its maximum and then start to fall off. So this is an important point here. There's no coincidence in the way that I have this drawn. Average product of labor has to reach a maximum when it crosses over that marginal product of labor curve. And the reason it reaches that maximum is because it's equal to the marginal product of labor at that moment. So some labor amount has been hired that equates those two variables, and if I hire past that amount, then average product of labor is going to have to fall because the marginal observation becomes less than the average. So we've got 3 points here, right, and these correspond to different amounts of labor. There's the point of diminishing returns, which is number 1. If I hire past that amount, then I'm going to change output at a slower and slower rate. Point 2 here is the amount of labor that I can hire in order to maximize total product. And point 3 is the point at which average product of labor reaches its maximum. No coincidence in how this average product of labor is drawn. When it hits marginal product of labor, it has to be at its maximum.